All right, let's just dive right into this explainer and completely demystify a term we have literally all heard everywhere over the last decade: blockchain. Whether we're tracking the latest crypto trends or just reading up on the future of tech, it's that one buzzword that never ever seems to go away. But if we look beyond all the hype, what is it actually doing under the hood? Well, let's unpack the fundamentals together. We're going to rely directly on our source material to take what seems like a crazy, complex web of cryptography and turn it into something remarkably straightforward. To make this as easy as possible, we're going to unpack this in 5 quick steps. We'll start with the shared digital notebook, move into the anatomy of a blockchain, look at nodes, networks, and consensus, ask, is it just a database? And finally, wrap up with the big picture. So we have to start with the most fundamental question, right? Stripping away all the technical jargon. What exactly is a blockchain? When we hear the word, our brains almost automatically jump straight to Bitcoin or, these wildly complex computer algorithms. But I wonder, if we just forget about the digital aspect for a second, what real-world purpose does it actually serve at its absolute core? Let's start with step 1, the shared digital notebook. At its foundation, a blockchain is simply a ledger. That's it. Imagine you and a group of friends sharing a physical notebook. If you send your friend Bob $100, Bob sends Charlie $40, and Charlie sends David $20, you just write those transfers down on a page. That notebook just keeps track of who transferred what to whom. Banks use ledgers, businesses use accounting ledgers, and fundamentally, blockchain networks are just maintaining a digital version of this exact same notebook. But here is where things get really interesting. Notice the massive shift in power here. With a traditional, centralized ledger, your bank holds the one true copy of your transaction history. They are completely in charge. But with a distributed ledger, imagine that instead of one central boss keeping the notebook, thousands of computers around the entire globe have their own identical, up-to-date copies of it. This shift from a single central authority to a massive distributed network is literally the absolute bedrock of all blockchain technology.
Okay, moving right along to part 2, anatomy of a blockchain, blocks, chains, and trains.
To really visualize this, think of it exactly like a massive freight train moving down the tracks. A blockchain consists of a sequence of blocks connected together. Each car on this train is a block of information, and they are linked one after the other in a very strict chronological chain. You absolutely cannot just shove a new train car into the middle of a moving train, right? It always has to attach securely to the very end. So what's actually packed inside these train cars? Well, instead of recording every single transaction completely independently, like treating every transfer as its own separate book, the network bundles them up. Inside each block or train car is a bundle of grouped transactions, a timestamp of the exact moment it was created, some general block data, and crucially, cryptographic information that links it directly to the previous block. Now, that cryptographic reference linking the blocks together, that relies on something called a hash. You can think of a hash as a highly unique digital fingerprint for a specific piece of data. Basically, the network takes all the information inside a block, runs it through a crazy complex mathematical formula, and spits out this totally unique fingerprint. This is honestly brilliant, and it perfectly illustrates why these digital fingerprints are incredibly powerful for security. Check this out. Changing just one single letter from a capital B in Hello Blockchain to a lowercase b completely alters the resulting hash output. Because every block contains the hash of the previous block, if a hacker tries to sneak in and alter even one single decimal point in an old transaction, that block's digital fingerprint completely changes. And boom, that instantly breaks the connection to all subsequent blocks, sounding the alarm to the entire network. It is just an ingenious, self-securing mechanism. Which brings us to part 3. Nodes, networks, and consensus. Okay, but if thousands of people are holding this digital notebook, how on earth do they all agree on what gets written on the next page? Well, the network relies on computers called nodes. A node is simply a computer running specific software that participates in the blockchain network. Think of them as the worker bees. Depending on the specific network, they might verify transactions against the rules, maintain copies of the entire blockchain history, and constantly chat with other nodes to keep everyone perfectly in sync. So, how do these worker bees handle a real live transfer? It's a rapid 6-step journey. First, Alice creates the transaction in her digital wallet. Second, that transaction is broadcast out to the wider network. Third, the nodes grab it and verify that she actually has the funds and is playing by the rules. Fourth, if it's all good, her transaction is bundled into a brand new block. Fifth, that block is securely linked onto the existing chain. And finally, step 6, the transaction is permanently recorded, and Bob actually sees the funds pop up in his account. But wait, how do they agree on whether that new block of transactions is valid in the first place? Without a CEO or a central boss, the network needs a protocol. It turns out our sources highlight 2 main ways they do this, known as consensus mechanisms. There's proof of work, which is what Bitcoin uses, where miners compete to solve really heavy computational problems to add a block. And then there's proof of stake, used by Ethereum, where participants called validators secure the network based on the crypto they actually hold. Both beautifully achieve the exact same goal, distributed agreement. And here's a really surprising fun fact for you. Proof of stake actually uses roughly 99% less energy than proof of work. That is a massive, massive leap for network efficiency. All right, part 4, let's tackle a big question. Is it just a database? Time to bust a few myths. You've probably heard this quote floating around tech circles: blockchain data is immutable, meaning it can absolutely never, ever be changed. But the source material makes a really great point here. It isn't magic. Rather, the combination of cryptography, distributed nodes, and consensus mechanisms simply makes unauthorized alterations incredibly difficult. So it's much better to think of it as heavily resistant to unauthorized changes rather than some magical vault of perfect immutability. And look, traditional databases are absolutely fantastic. They are lightning fast because one organization completely controls the access and the updates. But blockchain intentionally trades that pure speed for decentralized trust. And this is exactly why this matters to you. It allows total strangers to agree on a shared state without having to trust a single central record keeper. It shouldn't replace every single database in the world, but it absolutely excels when multiple parties need to coordinate securely without a middleman. There's also this myth about absolute privacy versus complete transparency. While anyone can inspect transactions on a public blockchain, they typically only see wallet addresses. So you might see that address A sent a bunch of crypto tokens to address B, but you definitely don't see someone's real-world name attached to it. The public ledger is entirely transparent about the movement of funds while keeping real-world identities separated from the actual on-chain data. Okay, part 5, let's wrap this up with the big picture. Let's rapidly synthesize everything so you walk away with a rock-solid foundation. If you take away just one core idea from our journey today, let it be these 7 things. Blockchain is a distributed ledger. Transactions are grouped into blocks. Those blocks are cryptographically linked together. Hashes act as unique digital fingerprints. Nodes maintain and communicate the data. Consensus mechanisms ensure everyone agrees without a boss. And finally, yes, it powers crypto, but it has vastly broader applications for how we manage trust across countless industries. So we've got the fundamentals down, but here is the million-dollar question. When you open an app on your phone and press send to pay a friend, what is actually happening out there in the dark forest of the network to make that a reality? Well, we are going to tackle that exact step-by-step live transaction in our next explainer. Until then, keep exploring, and thanks so much for learning with us today.